what equipment we use to detect radiation from the nucleus, alpha, beta, or gamma? We need a GM tube connected to a suitable counter. Before any experiment with radioactivity, we need to know the background count. What are the sources of background radiation? There are natural sources and man-made sources. We are recording here without any additional sources in the room. We're recording for 100 seconds. And we see that after 100 seconds, we have a count rate of 36. If we repeat the experiment, do we expect exactly 36? If we get 33, is that wrong? Does that signify an error? What do we know about the nature of radioactive decay? Let's try that again. So there we go. I would leave that to get to 100. As a hint, let's just consider how does radioactive decay relate to dyes. How can we model radioactive decay with dyes? What do they have in common with the decaying nucleus? These are 10-sided dyes, and if we how does that relate to which nucleus will decay? What is constant in throwing at dyes? In this example, a 10-sided dice. What do you think is constant when a radioactive nucleus decays? So we are now on 20 counts and we're approaching the 100 seconds. So let's have a look. Let's see where it will stop. So 26, 27, 28, and we're almost there. So we have 29 counts in 100 seconds. Now let's add a radioactive source, something that you can actually buy at the supermarket. So here we have low sodium salt. We have poured in a beaker, and we're going to add that beaker under our GM tube. We are going to reduce the distance. Why should we reduce the distance? Is there any of alpha, beta, or gamma that would be affected by the amount of air we have between the source and the GM tube? Now you can hear it going, so let's restart the count. So you can see definitely low sodium salt is radioactive. But no worries. The radioactivity, the amount of radiation, it's very small and it's not harmful. So we'll wait for 100 seconds. And we expect to see a number significantly higher than background. That tells us that we have a radioactive source. What type? That will be the next experiment. So we're halfway through, more or less. We're already on 56, 58. Now remember, these are counts. In the time interval, we have set our counter, so these will be counts in 100 seconds. We can convert, of course, to counts per second, and that will be the same as becquerels. So we're already on 90 and going strong. So clearly, this is a lot higher than background. It cannot be explained simply by saying radioactivity is a random process. We're approaching 135. Probably will pass 150, I think. Almost 150. There we go, 150. We passed it. And that's it. 154 counts in 100 seconds. What kind of experiment can we do to work out what type of radiation it's emitted? Now I'm going to change the source for the next demonstration. So we're going to change the source to something that again we can buy from a DIY store. It's a gas mantle. Now most gas mantles are not radioactive, but they used to be, and this is one type that you can still buy and it is radioactive. So how do we safely handle radioactive source? We should try and keep our distance, and we should only use it when we're actually doing the experiment, minimize the time, etc. So let's put this under our GM cube. You can hear the counter going berserk, so definitely it's radioactive. So let's restart. Let's see what we get in 100 seconds. You may have been surprised how radioactive this is. So we are already on 200 and we have only been running the experiment for a few seconds. Oh, we're still going strong. Probably will pass 1,000 easily. Now, is it alpha, beta, or gamma? How can we identify the source, the type rather, of radiation emitted by this source? Remember, alpha can easily be stopped, a few centimeters of air or a piece of paper. Beta can easily be stopped by aluminium, a few millimeters. But before you do any of such experiment, you need to know the background so you can compare. When we say it will be stopped, we mean the count will drop more or less to the background level. So let's see where we are. Oh, we are already on 1300 and we still have some time to go. Now remember, this is the count in 100 seconds, from which we can find the count per second. But is this the activity of the source? Well, it's not. Why is this not the activity of the source? Remember, activity in becquerels is counts per second. Just converting to counts per second does not make this the activity of the source. Can you give a reason? So we are already at 100 seconds and we see 1,801 counts. Okay, we'll add now some paper, piece of paper between the source and the GM cube without changing any of the distances. So we'll restart it. It has definitely slowed down, but it's still going strong. If we see a significant drop with paper, what can we deduce? Remember, alphas do not go through paper. If it doesn't drop to the background, that definitely means there is something else except alphas. It could be betas, gammas, or both. So, still going strong with the paper in place. And as you can see the distances, we have made sure that it's under 5 centimeters between the source and the GM cube, so definitely alphas can reach it if the paper wasn't there. We're coming close to 100 seconds soon. Probably this would get to 1,000, showing a significant drop, but definitely way above background. So clearly we can conclude that If that's the case, alphas are present, but definitely not the only emission. Okay, so 1044 in 100 seconds, definitely a drop, but still way above background. We will change the paper to aluminium. So we take the paper out and we add an aluminium, piece of aluminium. Let's restart it. It has definitely slowed down significantly. Remember, all the alphas were stopped by the paper. The aluminium will also block betas. So now alphas and betas are blocked. Only very high energetic betas may go through, and their numbers will significantly be reduced. So a significant reduction compared to paper will definitely indicate the presence of betas, and if it doesn't go back to background, even with the aluminium in place, we can conclude that gammas are also present. How can we stop gammas, or at the very least significantly decrease our exposure to gamma? We can use lead. Very thick piece of lead will definitely stop most of the gammas. So we are getting to our 100-second mark, and there's definitely a significant drop. So this source definitely emitted betas, and you can estimate how much of the count was due to beta. Remember to always correct for background. How do we correct for background? We need to subtract the background count for the same time interval from what we get. So there we go, 316 counts.